friends, good to see you all. Sorry I'm not there today, but we are going to do our final review. Remember, we're going to do final review today and then on Monday. So let's talk about what that's going to look like. So over the last few months, since our midterm in October, oopsies, moving things. Since our midterm in October, we've talked about simplifying expressions, solving one-step equations, two-step equations, multiplying with integers, variables on both sides, simplifying and solving, and mixed and improper fractions. Okay? So what I want you to do now is to think about those topics and write down which one was the easiest for you. And that might mean that you still remember it, or you feel like you got a good quiz grade on it, or whatever it might be that makes you feel like that was your best topic. Okay, terrific. And then, now I want you to do the kind of the opposite. So thinking about those same skills, which one was the hardest for you? Maybe you missed a day, maybe you didn't do very well on the quiz, maybe you can't even remember what we talked about that week. Which of those topics was the hardest for you? All right, so no matter which one you picked, we are going to review each of those ideas over the next few days before our final on Tuesday. So we're going to start at the bottom, week 10, kind of work our way up. Today we're probably going to be able to talk through these 3 skills right here, and we'll save these other 4 for Monday. Okay, so we're going to talk about simplifying expressions, one-step equations, and two-step equations, and we'll go from there. Alrighty, so on this next part, we were talking about like terms and how do we simplify with those like terms, and then distributive property. Okay, so you may or may not remember exactly what these look like. But I want you to think about combining like terms first. My hint to you guys is that it involves Snickers and Nerds. So in the box, I want you to write an example of a combining like terms problem. If you're not sure, just do your best guess, okay? All right, perfect. So when we talk about combining like terms, one of the things that you should think about is that we're going to have some terms or some things that we're adding and subtracting. Okay, that also have some variables with them. And so you might have something like 3b plus 2b plus 5 minus b. Okay, this problem has some terms that can be combined because they have the same variable in them. Okay, now on this next one, I want you to write a problem that has distributive property in it. So thinking about bunny hops, what might a problem look like that we've dealt with that has distributive property in it? Terrific. So our types of problems are going to have a number or a variable. I guess we haven't done one of those types, but you could have a variable at the front. And then some parentheses, and within the parentheses are going to be at least 2 terms, one of them having the variable at least. Okay. And so this was type of problem that we were talking about when we were talking about distributive property. Here are some other examples of that. All right. Okay, so you can see this problem right here, 4b plus 6 plus 5b plus 7. Again, terms that have similar variables or the same variable. And then distributive property, a number in front of parentheses, and 2 terms on the inside that we can't combine. Okay. So let's look at this problem over here. This is a combining like terms problem, and I guess we must have talked about it on Monday. So what I'm going to do and what you're going to do when you come to a problem like this on the quiz is you're going to identify the like terms. So what is the term that goes with this 7b? Terrific. Now be careful. If you said just b or just 5 or any of those things, make sure that you include the negative as well, okay? So it's 7b minus 5b. And what do you get when you take 7b minus 5b? Great, you're going to get a 2b. to be or not to be. And then we have what other terms are going to be left over. Yep, and again, we want to make sure we have the sign in front of this term. So it's plus 9 minus 3. And what do you get when you go plus 9 minus 3? Okay, you're going to get a positive 6. Now at this point, what do I want to do? Correct. I do not want to do anything because at this point I have a bowl of mashed potatoes and a bowl of ice cream. Neither one of those do I want to push together. So our final answer is 2b plus 6. Okay, the next type of problem was our distributive property. And we were noticing that it was distributive property because of those parentheses. And when we have parentheses, we think about math bunnies. And this 4 is a bunny. And that bunny is going to hop to each of the terms on the inside. So 4 and 6 and 4 and 5b. And at each of the terms, it's going to multiply. So we have 4 times 6, and we have 4 times 5b. And that 5b looks kind of funny, and that's okay. So when we multiply, we get 4 times 6, which is 24. When we multiply here, we get 4 times 5b, which is 20b. Okay, now what do I do with that problem? Correct, I'm going to leave it the same because again, I've got a bowl of mashed potatoes and a bowl of ice cream. They look similar, but they're not the same thing, so you don't want to combine them. Okay? All right, the next topic that we talked about. Yep, it looks like there's a delay here. What's going on? So the next topic we talked about was one-step equations. And we talked about this back in the end of October, beginning of November, so don't panic. And actually with this topic and this class, it kind of is really nice because all of the things that we've been learning keep building on each other. So if you're doing okay with the stuff that we were doing recently, then you're probably really good at the stuff that we were doing a while ago. Okay. So when we talk about our solving one-step equations, we need to think about identifying and comparing expressions versus equations, and identifying the opposites, inverse, and blah. So identifying the opposite or the inverse operations, and then solving those equations. Okay. So look at some examples here. When we think about the term algebraic expression, it has two parts. The first part being algebraic, which means it has a variable in it, and expression, which means it does not have an equal sign. So you can notice over here, this one has a variable, and there is no equal sign. A numerical expression, on the other hand, numerical means it just has numbers, no variables, and the equation part means that it does have an equal sign. So you can see no variables and an equal sign. So we get to this next one, an algebraic expression. Algebraic expression means it has a variable, and I read it wrong because that says equation, and an equation has an equal sign, which it does. So this is an algebraic equation. The last one is a numerical expression. So a numerical expression means numerical, it has a number in it only, and an expression meaning that it does not have an equal sign. The types of problems that we're going to be dealing with that we dealt with for one-step equations are algebraic equations. Okay, so those are the type that we're going to be focusing on when we're solving one-step equations. So a couple just reminders. The goal of solving an equation is to get the variable it's by itself. When we think of opposites, we're thinking about adding and subtracting, and the opposite of multiplying and dividing are those opposites. Our steps: draw the fence, do the opposite, do the math. Okay? So let's look at this first one. We can kind of do this one together. So tell me that first step on e divided by 5 equals 12. Great. We're going to draw the fence. Okay. What is keeping that e from being by itself, and what would be the opposite? Okay. It says e divided by 5. The opposite is to multiply by 5. And now we need to do the math. So what do you get on the right-hand side? And what's left over on the left-hand side? Yep, those 5s cancel, or left with an e. So e equals 60. Terrific. All right, the next problem, it says 4f equals 28. So what would be our first step? What's the opposite? Four and f are multiplying together, so the opposite of multiplying is to divide. Last step is to do that math. 28 divided by 4. F4's cancel, leaving us with the f equals 7. All right, try this next one. And if you want to talk through what it is that you're doing as you solve it, there's a way for you to record your voice, so you could do that. Okay, so you should get minus 8, minus 8, we get 13 and r. So 13 equals r. Last one. Again, try this one on your own, explaining how you did your math. Fence plus 6 plus 6, 18 plus 6, 24, c equals 24. Okay, perfect. So one-step equations, we've done them many times. You can also see the work here, kind of a little bit more color coordinated. All right, the next thing that we started talking about was two-step equations, right? Two-step equations, and again, not panicking. We started talking about a little bit more of those math words. So a variable, which means a letter or a symbol. We have a constant, which is a number that does not have a variable. It's kind of like the alone number. And a coefficient, which is the number in front, or that's multiplying with the variable. Okay, so when we were talking about two-step equations, we needed to identify the coefficient and the constant. There's also operations in these problems and an equal sign, but we've talked about those previously. And then this is just an example of the difference between a one-step equation and a two-step equation. Notice with our one-step equations, all of the problems have just one variable and one number. So one number is keeping that variable from being by itself. Whereas a two-step equation, how would you describe a two-step equation? Yeah, you could look here too, or however you described it. But a two-step equation has just one variable still, and it has two numbers that are keeping the variable by itself. One of those numbers is multiplying or dividing with the variable, and the other one's just kind of hanging out that by himself. And then on the opposite side, you'll see a number. Okay? And when we think about our steps, we again still draw our fence, we still do the opposite, and we still do the math. Just when we're doing the opposite, we want to start with our constant, the alone number first, and then we deal with the coefficient. So you can see that part here. Okay. 2p plus 3 equals 15. We subtracted the 3. It was the constant. Then we got 2p equals 12. So we divided by 2 because that was the coefficient. And we ended up with p equals 6. So let's do z-Savon. What is our first step? Okay, we are going to draw a fence on the equal sign. Whoa. Check that off. Now, I'm noticing that my variable is over here on the left side. Okay, which of those numbers do I want to deal with first? Yeah, I want to deal with this 6 first because that is the constant. It's the number that's all by itself. So what operation do I want to do? I want to subtract 6 on the left side and the right side. Okay. On the left side, what is left over? Terrific. These 6's cancel out, and then we are left with a 4x over here. On the right side, we have 14 minus 6. What do you get when you go 14 minus 6? Get an 8. Now we need to deal with our coefficient, right? It's the number that's multiplying or dividing with the x. In this case, it's a 4. So the opposite would be 2. Divide by 4 on both sides, which leaves us with x equals 2. All right, two-step equations. How are you feeling about those? Okay, hopefully it's going pretty well. Done them several times. The next thing we talked about, let's see, clear this, was our multiplying integers. Okay, so the positive and negative numbers. So remember we had negative things. Sometimes we have less than a positive situation. And we just had lots of ways to think about solving these types of problems, right? If a good guy that's positive comes to town, that's positive, that's a good thing. And if a good guy, which is positive, leaves town, which is negative, that's a bad thing. So we have those ones. We also had the Drake little meme over here. A negative times a negative gives us a positive. A negative times a positive gives us a negative. Positive times positive gives us a positive. We could also think about if they have the same signs, the answer is going to be positive. If the signs are different, then the answer is going to be negative. And then we had this little weird face, either Dorito Man face or our weird, goofy, strange plus minus face over here. Again, helps us to solve those integer problems. So let's look at this here. All right, the first one says 9 times negative 2. What type of answer is that going to give us? Yep, so when we're thinking about 9 times negative 2, I know I have a positive number and a negative number, so that's going to leave me with a negative answer. So we're going to have a negative 18 here. Okay. All right, next one says negative 9 times negative 2. So I'm looking down here. Okay. It says a negative times a negative is a positive. So that means I'm going to get a positive 18. All right. Last one over here says a negative times a positive. So I'm looking at my Drake example here. A negative times a positive is this middle one. Negative times a positive. So that's going to give me a negative 18. And you should already know that a positive times a positive is going to give us a positive answer because we've been doing those types of problems with positive numbers for a really long time. And so we've always only ever had positive answers for those ones. Alrighty. So going back to our list here. Beep, boop, boop, boop. Okay. Again, we were thinking about these. Oh, we actually did more than I thought we were going to do. We did these ones here. Hope you are feeling good about those. And then before you leave, make sure you tell the sub the secret word, which is elephant. Okay, that's how the sub will know that you have completed the Edpuzzle if you tell them the word elephant. All right, thanks guys. Bye.